Welcome to another warm-up. Give these three a try. Pause the video. See how far you can get. All right. Hopefully you gave that a try. At least got far enough so that you know where you got stuck, and I can try to unstick you. There are, of course, infinitely many examples for this first one, but here is a great one. How about x squared minus 1 over x minus 1? Why does this work? Because the top factors, you could have even given it in factored form from the beginning. No reason why you couldn't. This is a perfectly good way to write that. The thing here is that we would like to cancel those x minus 1s, and we are allowed to cancel those x minus 1s as long as x is not equal to 1. Great. So there's a nice example. If I was going to try to graph it, it just looks like x plus 1, which is a nice line of slope 1, except it's going to have a hole right at this point, 1, 2. And you could have done any of a number of other functions as well. All right, show that the absolute value of x is continuous at 0. If I want to show this formally, what this means is that we need to use some left and right-sided limits. So I'm just going to go ahead and do those. The limit as x goes to 0 from the left of absolute value of x, and I need to compare that to the limit as x goes to 0 from the right of absolute value of x. Let's do this nice and slow. If I'm coming from the left, then that piecewise function, absolute value, is going to give us a negative x. But this, from the left, negative x as x goes to 0 is still just 0. From the right, the absolute value is going to do nothing because the right of 0 is positive numbers. So this is just the limit as x goes to 0 from the right of positive x. But that is still just 0 because positive 0 as x goes to positive x as x goes to positive 0, it's still going to 0. If I put these together, I see that the limit as x goes to 0 of absolute value of x equals 0 because the left and the right hand side agree. And importantly, it's not just that the limit exists, it's also that, hey, if I plug in this number, the 0 here, into that function, then I should get the same value. Okay, so the limit agrees with the function value. So it's continuous. All right, so put in simpler words, what does it mean to be continuous? It means that if I want to find a limit, just plug in. Great. So if I want to show it's continuous, I need to find the limit and see that I get the same thing as plugging in. So I did. I took the left and the right-hand side. I showed they agree. If the left and the right agree, then the limit must exist. Really, we only do this left and right-hand side game if there's an underlying piecewise function. Otherwise, we usually don't bother. And then I compared it to what I get if I plug in, and they were all, in fact, the same, so it must be continuous. What a nice property. Okay, graph y equals e to the x by hand and describe its end behavior. What happens as x goes to infinity? And then I even included another one, by the way, the y equals x. So let's graph this by hand. It's definitely one you kind of just need to know what it looks like real quickly without thinking too much. So e to the x is never 0. It is always positive. But as x gets really, really negative, it goes down closer and closer to 0. And then it grows really, really fast as I go off to the right. This point right here is 0, 1. That's that y-intercept. It does not have an x-intercept. It just has this horizontal asymptote. So we're describing what happens as x goes off to infinity, which is going to be a lot of the upcoming section. In this case, as x goes to infinity, y is also going up to infinity. Right? That's that end behavior. And as x goes to negative infinity, so that's way off to the left, right? Positive infinity, we think of going this way. negative infinity, we think of going this way, all the way out. What is happening to my function values, to those y values? Looks like it is getting closer and closer to 0. Okay. And what we're going to have in this section is we're going to try to make that a bit more formal, and we're going to say, yes, the limit as x goes to negative infinity of e to the x is equal to 0. In other words, we have a horizontal asymptote of y equals 0. Okay. And on the other side, we'll say the limit as x goes to infinity of e to the x is infinity.